Every AI agent needs access to something outside the model. Maybe it needs GitHub, Slack, a database, a file system, Google Drive, or an internal API. The problem is that without a standard, every AI app ends up building one custom connector after another. One connector for Slack, another for GitHub, another for Postgres, another for Google Drive. That does not scale. It slows teams down, creates duplicated work, and makes integration quality inconsistent across tools. MCP exists because serious AI systems need a standard connection layer between the AI application and the systems where real data and actions live. So before we talk about agents sounding smart, we need to talk about how they connect safely and consistently to the outside world. Before MCP, the shape is usually messy. The AI app has one custom Slack integration, one custom GitHub integration, one custom Postgres integration, one custom Google Drive integration, and then more one-off integrations for every internal system. Each connector has to be built, tested, maintained, secured, and updated separately. That means the integration effort keeps growing faster than the value. With MCP, the mental model gets cleaner. Instead of wiring the host directly to every system in a custom way, the host uses an MCP client. The client connects to an MCP server. The server exposes the right tools, resources, and prompts from the system behind it. That is the big shift. MCP reduces connector sprawl by giving AI applications a standard path to the outside world. In this lesson, I want to give you one clean beginner mental model. First, we will define what MCP actually is in plain language. Second, we will walk through the simple architecture: host, client, server, and external systems. Third, we will make tools, resources, and prompts easy to understand without turning this into protocol jargon. And finally, we will look at how senior engineers think about MCP boundaries, permissions, approvals, logging, and what an AI system should never be allowed to expose. If you leave with just one idea, it should be this: MCP is not the agent. MCP is the standard way the agent connects to context and capabilities. By the end, I want you to think a little more like a senior engineer. Not just, can this AI connect to the tool, but what data should it see? What tools should it call? What needs approval? What gets logged? What should never be exposed? Those questions matter because the connection layer is where convenience can turn into risk if the boundary is weak. Model Context Protocol, or MCP, is an open standard for connecting AI applications to external systems. Anthropic introduced MCP on November 25th, 2024, as a standard for connecting AI assistants to the systems where data lives, including content repositories, business tools, and development environments. That definition matters because beginners often think MCP is another agent framework, or that it is the intelligent part of the system. It is not. MCP does not replace the model. It does not decide the business logic for you. It does not magically make tools safe. A better way to think about it is this: the agent or host needs context and capabilities, and MCP gives it a standard way to ask for them. So the agent does the reasoning, while MCP defines a cleaner path to the systems around it. The word context is important here. Context is not just text copied into a prompt. It can be live file contents, a database schema, a deployment record, a business document, or a safe tool result the model needs in order to reason well. MCP helps the host reach that context in a structured way, instead of forcing every app to invent its own connector format from scratch. So if someone says MCP is the agent or MCP is the model, That is the wrong mental model. MCP is not the brain. It is not the whole application. It is not the business logic. It is the standard connection layer that helps the host talk to useful external systems in a more consistent way. Now let's make the architecture simple. At the top, you have the host, which is the AI application the user is actually using. Inside that host, there is an MCP client. The MCP client opens and manages a connection to an MCP server. The MCP server is the program that exposes useful things from an external system. That external system could be a database, a local file system, GitHub, Slack, Kubernetes, or a business API. So the mental picture is AI app or host, then MCP client, then MCP server, then the real system behind it. That is the key split. The host is where the conversation and reasoning live. The server is where the integration lives, and the client is the connection layer between them. Once you see that split, MCP becomes much easier to understand. Start at the top. The host is the app the user interacts with. That could be a desktop assistant, an IDE assistant, a chat product, or another AI experience. Inside that host, the MCP client manages the actual connection to one or more MCP servers. So the client is not the server and the host is not the external system. Keeping those roles separate makes the architecture easier to reason about. The server is where the integration logic lives. It exposes capabilities from the external system in a structured way. That might mean tools the AI can call, resources it can read, or prompts it can reuse. The server acts like a controlled interface between the AI host and the system behind it. Behind the server can be many kinds of systems: a local file system, a GitHub repository, a Slack workspace, a Kubernetes cluster, a database, a business API. MCP matters because the host does not need a completely different connection model for each one. The shape stays more consistent even when the systems are very different. Inside MCP, there are 3 beginner-level building blocks that matter most. The first is tools. Tools are executable functions the AI application can call, like reading a record, opening a ticket, or running a safe API action. The second is resources. Resources are contextual data sources, like file contents, schema information, or API responses that help the model understand the situation. The third is prompts. Prompts are reusable interaction templates that help structure how the model should approach a task. So if a server exposes a database, it might offer a tool for querying approved data, a resource for the schema, and a prompt that shows the recommended way to ask for a report. That is why MCP is more than raw tool calling. It is a structured context layer, not just an action button. Think of tools as actions with structure. A tool might read a deployment status, search logs, open a ticket, or run an approved query. The important idea is that the host is not just receiving random text back from the model. The model asks for a named capability, and the platform decides whether and how to execute it. Resources are different because they are primarily about context, not action. A resource might be the contents of a file, a table schema, a document, or a status record. Resources help the model understand the situation better before it decides what to say or do next. Prompts in MCP are reusable templates or guided starting points. They help the host structure a task in a repeatable way. So instead of every user or every app inventing the task format from scratch, the server can provide a recommended prompt shape for a report, an analysis flow, or a troubleshooting task. Here is the mistake I see beginners make all the time. They hear MCP and say, so MCP is the agent. Not quite. The agent or AI host is still the thing reasoning over the user request. MCP is how that host connects to external context and capabilities. Another beginner mistake is assuming that once a tool is connected through MCP, it is automatically safe to use. That is also wrong. A connection standard does not remove the need for policy. If an MCP server exposes a dangerous operation, the risk is still there. So MCP helps solve the connector problem, but it does not remove the need for permissions, approvals, validation, and careful system design. A standard connection path is valuable. Uncontrolled access through that path is still a problem. This is worth saying plainly. Connected does not mean safe. A connected delete action can still be dangerous. A connected production credential can still be too powerful. A connected internal dataset can still be too sensitive. MCP helps standardize the path, but the engineering team still decides what should be allowed on that path. So the mature view is this: standards are helpful, but standards do not replace policy. You still need permission boundaries, approval steps for sensitive actions, logging, validation, and a clear list of things the AI should never see or do. The protocol helps organize the connection. It does not remove your responsibility to govern it. Senior engineers treat MCP as an integration boundary. They do not start by asking, can we connect it? They ask, what should the AI access? What tools should it be allowed to call? Which operations are read only and which ones need approval? What should be logged? What should never be exposed at all? Those are the right questions because MCP sits exactly where model reasoning meets real systems. If the boundary is weak, the AI gets too much power or too much sensitive data. If the boundary is well designed, the AI gets the right context, the right safe tools, and a clear audit trail. This is the mature view of MCP. It is not just an integration convenience. It is part of the control surface for governed AI systems. The first senior question is about data. Does the AI need the whole repository or just selected files? Does it need full database access or only a safe read path? Should it see raw customer records or only redacted fields? Strong teams reduce access on purpose. They do not treat more context as automatically better. The second question is about action. Which tools are safe to call automatically and which ones need a human approval step? Reading a status page is very different from changing infrastructure, deleting data, or opening a high-impact workflow. Approval boundaries should match risk, not convenience. The final senior question is about accountability and limits. What should be logged every time the AI touches it? Which calls need an audit trail? Which secrets, tokens, internal admin actions, or sensitive data sets should never be exposed through MCP at all? These are not edge details, they are core design decisions. So here is the summary. MCP solves the connector problem by giving AI applications a standard way to connect to external systems. The host is the AI app. The client manages the connection. The server exposes tools, resources, and prompts from the outside system. And the real engineering work is deciding what should be connected, what should be approved, and what should stay off limits. If this helped, the next lesson is the natural next step. The full MCP architecture in more detail, including host, client, server, tools, resources, and prompts, plus how approval and safety boundaries fit around them. Subscribe for more practical cloud and AI engineering explainers from Trustscrin Cloud and AI Engineering. Next, we should go one level deeper into the full MCP architecture itself. That means how hosts and clients relate, how servers expose tools, resources, and prompts, and where approval and safety decisions should sit around the protocol. That is the difference between recognizing MCP as a buzzword and actually understanding how to design with it.